All right, good morning, grade sixes. Okay, today we're going to be looking at equivalent ratios, all right? So we're going to look at this word problem first, kind of show you a visual of it, and then we're going to do the number way and also a pattern or table way. So Kim is planting a border in her garden in Trail, BC. She plants 5 daisies for 3 red petunias. Okay, so I'm going to write 5 to 3 right here. Okay, so the ratio of daisies to petunias, D and P, okay, is 5 to 3. So the question here is, how many petunias would Kim plant for each number of daisies? And we have 10 daisies, and we have 15 daisies, and we have 20 daisies. So what I'd like you guys to do, okay, is pause this video and try to come up with what you think the answer would be based on what you know about this ratio right here, which is 5 to 3. What did I do with this 5 to get to 10, 15, and 20 that I would have to do on the other side? Okay, so my big way of doing it is the number way. We'll do the visuals after. So what you have to ask yourself is 5 times something, okay, is going to equal to 10. Well, it's 5 times 2. So now the rule in ratios to find equivalent ratios is you do the same on the other side. 3 times 2 is 6. So here, okay, my ratio of 5 to 3 can also be 10 to 6. Alright? Well, now what we can do is make it times 3, and we get 15, so we do 3 times 3, which is 9. So 15 to 9 is another ratio. Okay? Now we know 5 times 4 equals 20, so we do 3 times 4, which is 12. So as you can see, okay, we can take a ratio, like let's say we have 4 to 2, and I want to find out what 8 would be, okay, with this one right here. Well, we multiply by 2 here, we're going to multiply by 2 here, and we're going to get 4, 8 to 4, okay? The big thing is, we're not going 5 times 3 and then 10 times 3 here and getting a different number here. We're using this ratio, okay, to find out the other ratios. It's a lot like an input-output machine in patterns and relations. So now let's do the visual. Okay, we have our color tiles here. So it says you can use color tiles to represent the plants. Use yellow to represent daisies. So this is daisies, and then petunias is red. So it says start with 10 yellow tiles, all right, because that's our goal here. Okay, so what I'm going to do though is group them into 5 right now. So we got 1, okay, 2 groups of 5. Okay, we have 10 daisies, all right. For every 5 yellow tiles, this is what a ratio is, guys, okay? It's if every 5 yellow tiles, you need 3 red tiles, okay? So here we have 2 groups of 5, so we have to have 2 groups of 3. So here, my ratio is 10 to 6, okay? So that's one way of doing it, okay? As you can see, we drew it out, right? And we have 1 group of 5 here, we have another group of 5 here, so we have 10 in total, and here we have 1 group of 3 and another group of 3. So, as we can see, that makes a total of 6 red tiles, okay? So my ratio of daisies to petunias, if I have 10 daisies, is 6 petunias, okay? Well, now Mr. S wants to know how do we get 15 yellow tiles, okay? So we had 5 to 3 as our normal one, and I want 15 now. So what you could do is 5 times 3 and 3 times 3 and get 9. Okay, but now we're showing color tiles here. So add a group of 5 yellow tiles. So I went 1, 2, 3, 4, 5, boom. Okay, 1, 2, 3, 4, 5. Let's go like this. And now we have a third group of yellow tiles with 5. Okay, so we have 15. Okay, we have 3 groups of 5. 3 times 5 is 15, guys. Okay, now we have to add another group of 3 red tiles. Okay, so we had 1, 2, 3. Okay, now we have 1, 2, 3, so we had 6. Now we add another group, which is 9, right? So our ratio here is 15 to 9. Okay, finally, if we have 20, all right, so we're going to add another group of yellow tiles. Okay, if we go 5 to 3, oh, my bad, sorry, 5 to 3, we're going to multiply by 4 now, so we need 4 groups of 5, right? So we have to have 3 groups of 4, so, or sorry, 4 groups of 3. So here we get 20 to 12. So our ratio should be 20 to 12 here with our color tiles, all right? So add a group of 5 yellow tiles. So I got 1, 2, 3, 4, 5. 1, 2, 3, let's go here, 5. Okay, 1, 2, 5, and then 5. So we have 4 groups of 5, all right? So that equals 20. Well, now we have to do this. We go 1, 2, 3 is 1 group, 1, 2, 3 is 2 groups, 1, 2, 3 is 3 groups, and 1, 2, 3 is 4 groups. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 red tiles in this case. So our ratio here is 20 to 12. Okay, 1 second. Okay, let's say I wanted to do 25 daisies now with a 5 to 3 ratio. All right. So what I did here was 5 times 5, so I have to do 3 times 5. Sorry, and you're going to get 15. So what you could do is you could write 5 groups. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Right. 1, 2, 3. 4, 5, 1, 2, 3, 4, 5. So here, okay, sorry, these shapes are kind of odd. This is supposed to be a square. We'll just say squares, okay? We have 1, 2, 3, 4, 5 groups of 5, okay? So we have our ratio of 5 to 3 here, but we're writing an equivalent ratio. Okay, now on this side, we have 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. Here we have 15 circles, okay, and we have 1 group, 2 group, 3 group, 4 group, and 5 groups. So here we have the same amount of groups, which is 5, but we're going to have a different answer because our ratio is 5 squares to 3 circles in this case, all right? Okay, another way, probably my favorite way actually is a data table. Okay, so you can use the table of patterns to find the ratios. So if there are 5 daisies for every 3 petunias, okay, like we have here, all right, what we can do is we can basically multiply by 5, okay, to keep finding out the pattern, all right. So here my pattern goes up by 5, right? We multiply by 2, 3, 4. If we did times 5, our next number would be 25. If we did times 6, it would be 30, right? Whereas here, we're going up by 3, right? So we did 3 times 2, 3 times 3, 3 times 4. The next one would be 15, then 18, right? And we can keep finding out the ratios, right? And then match these two based on this data table. So here, the big thing is, okay, if we have 5 daisies for every 3 petunias, we have 10 daisies or 2 groups of 5 daisies. 15 daisies or 3 groups of 5 daisies, and 20 daisies or 4 groups of 5 daisies. So it just says the ratios up here or down here, okay? So it says the ratios of daisies to petunias are 10 to 6, 15 to 9, 20 to 12. We could write 25 to 15, 30 to 18, okay? But what we basically know is that the ratio is 5 to 3, right? We could write it like this, but these are all equivalent ratios, right? If I was to say, okay, 25 to 15, and we talked about simplifying the other day, you're going to divide this by 5 and this by 5 because there's a common factor between those, and you're going to get 5 to 3. So now what I want you to do is pause the video, okay, and I want you to come up with 2 equivalent ratios for each of these. Ready, set, go. Okay, so I'm going to write this first one out here. We have 3 to 1. Okay, so the easy ones, and that's all I'm going to do today, is I'm going to multiply by 2 on each side, and I'm going to get 6 to 2. That is an equivalent ratio, okay? Now I'm going to take 3 to 1, and I'm going to multiply by 3 here and 3 here, and I'm going to get 9 to 3. All right, that's an equivalent ratio. Let's take the next one, 5 to 2. We're going to multiply by 2, multiply by 2. We're going to get 10 here to 4, all right? Now we're going to take 5 to 2 again. We're going to multiply by 3 now, and we're going to get 15 to 6. Okay, 6 to 3, I'm going to write here. We got multiply by 2, multiply by 2. Okay, we're going to get 12 to 6, all right? Now if we do 6 by 3, we multiply by 3. Okay, we're going to get 18 to 9, all right? And it's funny because 6 to 3, guys, is basically saying that this ratio is 2 to 1, right? So we have 2 to 1 here, 2 to 1 here, 2 to 1 here, right? It's everywhere, okay? All right, 7 to 4, okay, we're going to multiply by 2. We're going to get 14 and 8, all right? Go 7 to 4 again. We'll multiply 3 this time. We'll get 21 to 12. So the big thing, guys, is if you're doing an equivalent ratio that is higher, okay, then you need to multiply by something on both sides, okay? That's the big thing there. So here, let's take 1 to 2. Let's multiply each of these by 100 instead, okay? We're going to get 100 to 200, okay? That's the same ratio as 1 to 2, okay? We could take 1 to 2 and multiply it by 1,000. And we're going to get 1,000 to 2,000. So as you can see, the big thing is that you do both on both sides. So you can also create equivalent ratios by simplifying them, okay? And simplifying basically means making it smaller, all right? So simplifying is finding a common factor between them and dividing by that factor. So I have an example here, 6 to 3, okay? We can divide these two numbers by 3, okay? We know that our common factor is 3, right? If I'm saying what are the factors of 6, you're going to go 2 and 3. Okay, if I'm saying 3, you're going to go 1 and 3. My common one is 3. So here, okay, it is a common factor between the two and get a new equivalent simplified ratio of 2 to 1, all right? You can simplify until there are no more common factors between the two. So here, 2 and 1 is the lowest we can go. So if we took 1, okay, we have 1 as the factor, and 1 and 2, we have 1. So we cannot go any smaller. Okay, here's one more example, all right, and then we have a couple we'll do together. In this example, 8 and 16, we can find that common factor between 8 and 16 is 4, right? So if we go 1 and 16, 2 and 8, and actually 8 is 2, but we're just going to do 4, okay? So we have 1 and 2, 4 and 8, all right? So actually, let's do 4, okay? You can do 8 though, knowing that you know factors, all right? So we can divide by 8 by 4, okay, and 16 by 4, and get the new ratio of 2 to 4. So if I have 18 to 16, I would divide by 4, divide by 4, I got 4 here, sorry, no, 2 here and 4 here, okay? Now, these two numbers, we can find that common factor between them is 2. So we can divide by 2, and we'll get 1 to 2. So here, our ratio becomes 1 to 2. Okay, you might have done this too, knowing your factors. You could have divided by 8 on each side and gotten 1 to 2. So a couple practice ones here, okay? I want you guys to pause your video and then practice. We're not going to go through all of them, but we'll do them quickly, all right? Okay, so 12 to 4. Okay, very easy, all right? We have 4, all right? And we get basically 3 to 1, all right? Okay, the next one, 18 to 12, all right? We could go 4, but we could go 6 as well, okay? And we could get 3 to 2, all right? Let's skip, 24 to 6 is fine, yeah. 24 to 6, okay? We're going to divide by 6 on each of them, because that can go, 6 can go into 24, and we're going to get 4 to 1, all right? 9 to 12, okay, we're going to divide each of these by 3, and we're going to get 3 to 4. 8 to 64, okay, well we know 8 goes into 64 one time, and then this is 8. I'm going to scribble them out actually as I do them here. Let's do 15 to 5, okay. 15 to 5, we can divide by 5 on each side, and we'll get 3 to 1, all right. And then 30 to 40, let's go, okay. My common factor is 10, my greatest common factor, all right, so I'm going to get 3 to 4, which we cannot simplify anymore. Okay, that concludes everything. I got to hurry up because I only have 15 minutes in these videos. You guys know where the assignment is. It's in your OneNote or on your blog, everyone, okay, in Miss Debkers. You have to do the textbook assignment, all right? It's in your package, it's in OneNote, or it's in the textbook. Enjoy. If you guys have any questions, message me on Teams. Peace out.